In this lesson, we're going to begin talking about equations. And particularly, we're going to be looking at one-step, two-step, and multi-step equations. Before we dive on into solving, I do want to talk about some different notations that we're going to be putting our answers in once we complete the problem. This first notation is called set notation. And by the way, these notations are going to follow us throughout the entire course of algebra. So I wanted to introduce them to you early so that you could get a really good grip on how they're used. So a notation is really just how you're writing an answer. So I'm just going to show you a couple examples of what it looks like. So this first one is set builder notation. Sometimes it's just called set notation, but they mean the same thing. So let's say that I'm working with a problem and I just come up and I solve it out and I get an answer of 3. So I just have one answer to the problem and it's 3. This is how I'm going to write it in set notation. Now here's what it is. You use these little squiggly brackets. Then you write the variable that you're working with. In our case, we're working with the variable x. You might be working with a different variable during different situations, so just be aware that whatever the variable is, you need to make sure that you use that proper variable. So squiggly brackets, x. Now, this little line right here, this little line means, I'm going to write it right here, means such that. So x such that, then you're going to write your answer that x is equal to 3. That's the answer that you got. And that's it. That's how you write it. Sometimes as we work along during the course of the year, we're going to have answers there are 2 of them. So here's how you write set builder notation with 2 answers. So I would just write it as x such that, and then my 2 answers, x is equal to 3 and x is equal to -2. And then I would end my little squiggly brackets. Okay, sometimes, we're going to get into this a little bit later on, but sometimes all solutions work. So all real numbers, all numbers that are part of the real number system will be possible solutions to the problem. And don't worry, we're going to talk about the different scenarios where that occurs. But this is how you would write it. It said x such that x, and this little guy right here, this means exists. So it means x such that x exists, and then this cool looking thing over here, this is the actual symbol for real numbers. And I know that's printed, so the way that I write it is like this. I write 2 lines, and then I finish off the R. So it's really just writing an R with an extra line. So x such that x exists in the real number system. Okay, so that right there is set notation. Now I want to show you something that is really similar but slightly different. This is called roster form. So roster form is basically the same thing as set notation without all the X's and the lines. So if my answer is 3, I literally just write my little squiggly brackets with a 3 in it. And if I have 2 solutions, I just write my little squiggly brackets with my 2 solutions in it. To be honest with you, you usually don't use roster form when you have all real numbers. You can. It's not really a problem, but you could write it like this. But to be honest, most time when you see it, you're just going to write your answer as like this: all real numbers. And I don't want to confuse you. Don't worry, I'm going to show you multiple examples as we proceed through the unit on how this works. But I just wanted to kind of expose you to it up front. Okay, let's go ahead and move on to one-step equations. Oh, I'm sorry, 1- and 2-step equations. We're just going to do 4 problems because I do know that you are familiar with this from your years past. So the key to know with solving 1- and 2-step equations is that you're always using the opposite operation. So just remember that plus, our adding and subtracting are opposite operations of each other, and then multiplication and division are opposite operations of each other. Now, We all come from different elementary schools, so everyone might look at this a little bit different, but what I'm going to be doing is setting you up for harder problems. So I would prefer that you did follow the method that I'm about to show you and show by showing your work for the procedure. So in this first example, you can see that I have 3x equals negative 18. My goal is to solve for the x. So right now, 3 and x are being multiplied by each other. So I want to do the opposite operation. The opposite operation is division. So I'm going to divide both sides by 3. I'm always dividing by the number that I'm trying to eliminate, which is that 3. Now, I would like to make a note that I do not want you to do this because this is going to confuse you later on. I do not want you to write like this, divide by 3 or anything like that. That is not going to work. So please use your fraction bar going forward. Also, if you don't use the fraction bar, I'll be honest with you, it looks kind of silly in upper level math. So start moving into using the fraction bar and dividing underneath. Okay, so what happens is the 3 and the 3, well, we know that 3 divided by 3 is 1, so we can really eliminate those 3's, and we're left with x. I'm going to carry down my equal sign, and then I'm going to finish the problem. Negative 18 divided by 3 is going to give us negative 6. And I always, I just double check my answer and just make sure everything looks good. And you can put this in either set builder or roster form if you would like. I'll go ahead and do that on the side here. So my set builder notation would look like this. X such that x is equal to negative 6. And my roster form would just look like this. Okay, let's do another one step. So this time you can see that I'm trying to eliminate the 5, so he goes away from the x. Now I know when you look at this, you might know the answer to this, and that's great. But I do want you to show all of your steps. So we're trying to eliminate the positive 5. So the opposite of a positive 5 is going to be a negative 5. So we're going to subtract 5 from both sides. And notice how I'm drawing a little line right here. That means equal to. So please don't forget about that line. And then we're going to do the problem. 5 minus 5 are going to cancel out to give us 0. Positive x, I'm just going to carry down. I'm going to carry down my equal sign. And then negative 3 minus 5 is going to give me negative 8. And that's my answer. So I'm going to go ahead and write it in set notation first. So x such that x is equal to negative 8. And then roster form, I'm just going to put negative 8. Okay, those are one-step equations. Now let's go ahead and look at two-step equations. All right, this is a really common one where mistakes occur, so I wanted to bring this one up. So what I find common that students will do in this kind of problem is I can identify that I want the x. So students look at that positive 7 and they want to subtract 7 first. And that is not what you do in this problem. So I like to look at it like this. If you have a fraction, you always want to eliminate that denominator first. So the way I'm going to do that is I'm going to do the opposite operation here. And you can see that to get rid of negative 15, right now he's being divided. So I'm going to multiply both sides by negative 15. And notice how I'm writing out my steps. I do want you to do that, please. Okay, so now I have 15 is equal to, what's going to happen here is these negative 15s are going to cancel out, leaving me with a simple x plus 7. Now you can see that I just have a one-step equation left. So I'm going to go ahead and solve it. Now my variable is on my right-hand side, but that really doesn't make a difference. I'm going to eliminate positive 7 by doing the opposite, which is subtracting 7. Draw my line, and I'm going to end up with 8 is equal to x after my 7's are eliminated. Now in algebra, you always want to have the variable on the left side. So once you get to this point, go ahead and flip it over. X is equal to 8. And I'm going to quickly go ahead and write that in set notation. So x such that x is equal to 8. And I'm going to do my roster form as well. There we go. Okay, here we go. Now we have another two-step equation. Now this is another common area where mistakes occur. So I want to eliminate my 9 first. So let's go ahead and eliminate the 9 so that I get the x by itself. So it's a positive 9, so I'm going to go ahead and subtract 9 to eliminate it. So I'm going to get negative 11 is equal to, now this is where the mistake occurs. Sometimes students will just bring down the x, but I still have that negative there. So make sure you bring down a negative x. Well, I'm not fully finished because x is not by itself. Do you see who's here? Harold's here. The negative is in front of the x. So really what that is negative 1. So I have to eliminate it. Negative 1 is being multiplied by x, so I'm going to divide both sides by negative 1 to eliminate it. That's going to leave me with 11 is equal to x. And of course, my last step is just going to be to flip it over. And I'm going to go ahead and put it in set notation. So x such that x is equal to 11. And then my roster form, 11. Personally, when I'm doing math, I do like to put a box around that answer. So I'm just going to go back and I'm going to put a little box around my answer just to keep myself organized. The more you stay organized in Algebra 1, the better you will perform. Okay, so let's move on to multi-step. These are the majority of the types of problems you're going to be working this school year. We're kind of moving away from the whole 1 and 2 step and moving into this concept of multi-step. It just means 3 or more steps. So when we look at this problem, we can see that we definitely have a distributive property in here, right? If you have parentheses with a number outside, you have the distributive property. And you always want to take care of that first before you do anything else. So let's go ahead and let's do that. So I'm going to rewrite everything. And notice how nice and neat and organized I stay with my work as I work through this problem. Everything else that I don't use, just like we talked about in Unit 1, I'm just going to bring down. Then I'm going to go ahead and I'm going to distribute my negative 8. You always want to look at that operation in front of the number and grab that with you. So negative 8 times x is going to give me negative 8x. And then negative 8 times positive 4 is going to give me negative 32. Okay, that's step 1 of a multi-step equation. Now, the second step is going to be to combine like terms. So you always want to distribute first and then combine like terms. So what can we combine? It looks like we can combine the negative 7x and the negative 8x on the right-hand side. So let's go ahead and do that. I'm rewriting everything as I go along. Okay. What that did was it got me to a regular 2-step equation. So I'm just going to go ahead and now solve it using all the skills that I have from 2-step equations. So I'm going to go ahead and I'm going to eliminate the negative 32 by adding it to both sides. Notice how I'm writing plus 32 and plus 32 on both sides. And then I'm going to go ahead and simply solve it. So I have negative 60 is equal to negative 15x. And my 32s are going to cancel out because that was what I was trying to do. All right, the last step that I want to do here, I want to divide both sides of the equation by that number that's bothering the x there, negative 15. Notice how I write all my steps here. Okay, so 4 is going to be equal to x. And of course, I'm going to go ahead and flip that over. And I got my answer as x equals 4. I could go ahead and write that in my set notation just to get the extra practice. X such that x is equal to 4. And my roster form, which is 4. Okay, now you can see that I have this word check over here. The cool thing about all equations is that you can check them to make sure it's correct. And you can know that you got a perfect score. So let me show you this process on how to check it. It's kind of cool. So what I want to do is, actually I'm going to change my pen color real quick. We'll change it to green. And what I want to do is I want to rewrite the original problem. So let's go ahead and just rewrite the original. And just as a reminder, this works for every single problem. So feel free to use this as a tool to help you get them all correct. And now what I want to do is that answer that I got at the bottom, I want to go ahead and substitute it into the value for x. So I'm going to use the substitution property to check my answer. So I'm just going to go ahead and take a second. And this is a lot like evaluating expressions like we talked about earlier, but instead now we're just evaluating an equation. Now what I simply want to do is just use my order of operations and figure out if they are equal to each other. So let's go ahead and do that. I'm going to go ahead and take it nice and slow here. You can see that my first order of business here is 4 plus 4, which is going to give me 8. And then I have some multiplication to take care of. So I have negative 28 minus 64, which you can see, indeed, it is equal to negative 92. So you can see that this is the method on how to check it. If both of the numbers on both sides of the equal sign at the end up the same, that means you did it correctly. If they end up differently, that means there's something wrong in your original problem. So use this skill to help you get the answers correct. Okay, I do have two very unique problems that I want to show you. Something that occurs in Algebra 1 are these things called special cases. It's special events that occur that you might get an answer that looks a little bit different than what you're used to. So let me show you this first example. Okay, so we're also going to get some extra practice with our multi-step equations through these examples, but they're kind of unique. So let's go ahead and look at this. The first thing I want to do, of course, is distribute. So let's go ahead and take some time and distribute. And feel free to pause the video and try to work this problem on your own. It might be a little weird when you get to the end, but I'll explain it as we go along. Okay, so we've done the distributing at this point. So let's go ahead and combine whatever we can. So you can see that I have some n's to combine. So I'm going to go ahead and combine them. And when I do that, negative 24n plus 24n, right? If I combine these guys right here, don't they eliminate? Yeah, they do. They actually eliminate one another, which is kind of a problem because that's the variable that I am solving for. So let's just keep going to see what happens here. I'm going to rewrite negative 58 on the left. And then since these both went to 0, all I have left is my negative 6 minus 48. Do you see that? I'm going to go ahead and put a box around those. Those are like terms. They're constants. And that's going to be negative 54. But wait a second here. Those don't equal each other. So what does that mean? Well, when these don't equal each other, that means that this problem has no solution. And I'm literally going to write the words, no solution. What that means is that there is no possible value that I could put in for the variable n to make this equation satisfied, to make one side of the equation equal to the other side. So in this case, there's just no solution. So to be honest with you, there's no way to check it either. So you're pretty much done. Sometimes you might see no solution problems written in roster form and roster form only. And sometimes the way you might see it would look like this. This little circle with a line through it. Sometimes you might see that, and that represents no solution. Okay, so that's a special case. Now I'm going to show you another special case. Let's go ahead and solve this next problem. So let's go ahead and just take a moment and do some distributing. Feel free to pause the video and try to do this part on your own. Okay, now that we've finished distributing, we have to go ahead and continue the process of solving by combining like terms. So let's go ahead and combine. You can see that we have variables, the variable x we can combine. So if I take a second and I combine these, it just so happens to be the same number as the original problem that we just did, but that's just a coincidence. But you can see that these are going to eliminate again. And we're going to be left with 18 plus 40 with my other terms. And that's going to equal 58. So let's just go ahead and simplify that down here. 58 is equal to 58. Notice how in this example, they're equal to each other. That means that this is a whole different type of special case. This is called an all real numbers. All real numbers means that any number in the real number system, if you were to substitute it for your x values in the problem, every single number would make the equation satisfied, or would make the left equal to the right. How cool is that? So for this type of problem, it is all real numbers. So you can write this in set notation, and we did this earlier. It would look like this: x such that x exists in the real number system. We usually don't use roster form for this, but if you were, it would look something like this. But we usually don't see that. We more so see the set notation. Now, one thing I do want to make a note of is that when you're working problems that have special cases, you might identify the special case way back in the first step. You might eliminate those variables and then identify, oh, I know this is a special case. I can do the rest in my head. I want you to go all the way down to this point in the problem. Both in the no solution and the all real numbers. I want you to go all the way down to the bottom and prove to me that they're equal. Because sometimes they actually don't, and you misrepresent the problem. So take it all the way down and then indicate whether it is no solution or all real numbers. Now, with the all real numbers example, you actually can do a check step, because think about it. If every single number is going to work in the equation, then you can test any number that you like. So personally, I like to check nice, easy numbers. What I mean by that is I like to test the number 0. You could test the number 1 or 2. That would work, just as fine. But remember, 0 will eliminate numbers using that multiplicative property of 0. So I'm going to go ahead and show you how that works. You do need to do a check step for all real numbers whenever you're practicing this, please. Notice how I'm using my parentheses to substitute that replacement value into my problem. Okay, now I'm just going to do some order of operations, that's all. Alrighty. So you can have 18, and you can see that negative and a negative is going to give me a positive 40. And this is looking pretty good. I'm going to take it all the way down to the bottom where 58 is equal to 58. And that makes the statement true. Now, be very careful. 58 is not your answer. So sometimes I will see, situations where we write the answer as x equals 58. That's not, it is a solution, but the actual solution here is all real numbers. This is just the answer to the check step. So again, you can use any number that you like. I like to use 0 because it eliminates things pretty easily, but feel free to use 1 or 2. Those are other common numbers to use. Okay, that brings us to the end of the lesson of basic equations, one step, two step, and multi-step. And feel free to pause the video and go back and review anything that you might need to.